The world we live in seems to us rather clear-cut. It's hard for us to imagine flying mountains, enormous space anomalies, or objects thousands of times the size of the Sun. However, a lot of what would normally seem to be a figment of one's imagination actually exists in the universe. However, it is billions of kilometers away from us. A perfect example of these eerie celestial objects are black holes. Their sheer existence was considered impossible until only recently, when on the 10th of April 2019, the National Science Foundation in the USA showed the world an image revealing a black hole in the middle of the Messier 87 galaxy. This object has a mass approximately 6.6 billion times that of the Sun, with a diameter of about 100 billion kilometers. Just to compare, the diameter of the Earth is only 12,742 kilometers. This hole falls into the category of supermassive black holes. A similar object can also be found in the center of the Milky Way. It is called Sagittarius A and boasts from 2 to 5 million times the Sun's mass, according to different estimates. The diameter of Sagittarius A is 45 astronomical units. In other words, 45 times the distance from the Earth to the Sun. But is it possible to admit of the existence of even larger black holes in space? And which of them is the largest? Let's figure it out. A black hole is a term referring to an area in space with an incredibly powerful gravitation in the center. As a rule, these objects are rather small at first and are able to expand as they actively build up their masses. Black holes are categorized according to their masses. The heavier ones are called supermassive black holes. Those of them whose masses reach from 100,000 to 10 billion times the mass of the Sun fall into this category. At the moment, scientists haven't formed a unanimous opinion as to how these objects come about in space. According to the most popular theory, that of gradual expansion, when a black hole appears, it has a mass typical of a star, and later on it grows by sucking in the surrounding matter. The amount of information accumulated by science about these objects is rather scarce, but even based on the current data, a supposition can easily be made about there being at least several such holes in the center of any large galaxy. In the time the universe has existed, a few million or even billion of black holes are likely to have been formed in it by now. At least today, only a small fraction of them is known to us. The champion in terms of its mass is the black hole in the center of a quasar known as TUN 618. This object was stumbled upon in 1957 when white dwarfs were being explored and initially caused a lot of puzzlement on the part of the scientists. The notion of quasars was to appear only 6 years later. That is why the nature of the object was rather vague. On photographic plates taken with a 0.7-meter Schmidt telescope, it was listed as number 618 and described as decidedly violet. It was only in 1970 that radio emission from TUN 618 was discovered at the Institute for Radio Astronomy of Bologna. This emission was indicative of the fact that it was a quasar, and moreover, the most luminous quasar known to science at the time. It is assumed that there's an accretion disk of hot gas in TUN 618 surrounding a gargantuan black hole in the center of the galaxy. The gas must move around the disk at a tremendous speed, reaching 7,000 kilometers per second. This object is located in the constellation of hunting dogs, or Canis Venatici, and is 10.37 billion light-years away from us. The galaxy containing TUN 618 cannot be seen from the Earth due to the luminosity of the quasar itself, which is 140 trillion times as intense as that of the Sun. The contemporary view on quasars defines them as active nuclei of galaxies at the first stage of their formation. the nuclei's supermassive black hole sucks in the surrounding matter, thus forming an accretion disk. This disk is the source of luminosity of enormous power that is sometimes more intense than the aggregate luminosity of all stars and galaxies like ours. The brightest quasar, which was discovered in January 2019, has the luminosity of about 600 trillion suns and is 12.8 billion light-years away from the Earth. What could be the mass of an object finding itself in the center of a light cannon like this? According to today's estimates, the mass of the black hole in the center of the TON 618 quasar reaches 66 billion times the Sun's mass, which makes it the heaviest black hole in our galaxy known to science. Black holes of this mass are categorized in a different group and are referred to as ultramassive black holes. In fact, the TON 618 quasar isn't the only object in this category. Within the constellation of Cancer, for example, which is 3.5 billion light-years away from us, the OJ287 quasar is to be found. It has a black hole in the center and is 18 billion suns masses. In the center of the Phoenix cluster, there's a rapidly expanding black hole, which at this moment is 20 billion times the Sun's mass, building up 60 suns masses a year. One of the best-known black hole giants is located in the galaxy NGC 1277 within the Perseus constellation. The object reaches 21 billion suns masses, and its event horizon diameter equals 130 billion kilometers, which is 15 times the distance from Neptune to the Sun. However, at the moment, this giant practically isn't being active. Speaking about size, the undisputed holder of the first place on the list is admittedly another well-known space object, namely the black hole in the center of Holmberg 15A, a supermassive elliptical galaxy located in the constellation Cetus, or the Whale, 700 million light-years away from the Earth. This black hole isn't a champion in terms of its mass, which is 40 billion times the Sun's mass. Its dimensions, however, can't but amaze. According to today's estimates, the event horizon of this black hole could be as big as to accommodate the entire solar system. Its diameter is approximately 790 astronomical units. The Holmberg 15A galaxy must have been formed as a result of the collision of two smaller galaxies at some point in the distant past. A similar process is likely to be expected in our system as well, when the Milky Way collides with the Andromeda galaxy in 4 billion years' time. For now, astronomers plan to continue studying the phenomenon of the black hole in Holmberg 15A by carrying out complex and detailed modeling. Scientists are going to collate the results of theoretical calculations with practical observations in the future in order to try to establish how exactly it was possible for a tremendous black hole to come into being inside the two galaxies on their collision. In comparison to the objects mentioned above, our own planet may seem of no significance at all on the overall space map. But it should be noted that the age of practically all the supermassive objects in the universe is several times that of our Earth. For millions of years, these black holes have been gaining in their masses and expanding as the time went by. Today, we can observe their activeness as the result of the development of the entire universe. It is quite feasible that most of the ultramassive black holes were formed as a result of smaller holes merging. A similar process takes place when they collide, which is accompanied by the emission of gravitational waves. These occurrences must be the biggest contributors to the generating gravitational waves in the universe and are exceptionally attractive to scholars of gravitational wave astronomy. By now, several similar signals which came about as a result of two small black holes merging have been registered by the American observatory LIGO. Perhaps we will find out the names of other champions in the list of space giants in the near future. And now, all we have left to do is just await new, amazing discoveries. We respect our audience. That is you, dear viewers. That's why we try to bring under scrutiny the most fascinating and bizarre things that can be found in space. So diverse and amazing. That's why grab this mouse of yours and hit the like button under the video. It's your likes and comments that encourage us to explore new boundaries. We will make it beyond these only thanks to your support and your subscription to the channel. See you around, dear friends.